In this video we're going to have a look at product of primes. So there's a couple of bits of terminology we're going to use. We're going to use factors, so these are whole numbers that divide exactly into a number, and we're going to be looking at prime numbers. So these are numbers that are divisible by exactly two numbers, the number itself and one, and no other whole number is going to divide exactly into my number if it's a prime number. I'm going to start off by having a look at the number 6, and I'm going to draw a factor bug for 6. I'm looking for the numbers that divide exactly into 6. Well, I've got 1 and 6 itself. I'm going to write these in pairs, so I've got factor pairs because 1 times 6 is 6, and I'm going to write them in order. So the next number that divides into 6 is 2, and its factor pair is 3. 2 times 3 is 6, 1 times 6 is 6. The benefit of doing that is I've got 1, 2, 3, so I know I haven't missed any, and the factor pair of 3 is 2, which we've already got. At that stage I know I've picked up all of the possible factors of 6. So it's got 4 numbers, 1, 2, 3 and 6. Now 6 and 1, neither of those are prime. Remember, 1 is not a prime number. It has to be divisible by two numbers, 1 in itself. 1's only divisible by one number, 1. So 1's not prime, 6 is not prime, but 3 is, and so is 2. So I could write 6 as the product of, what I mean by product is times. So 2 times 3, so I've got the product, the multiplication of two prime numbers, 2 and 3. So 6 is equal to 2 times 3, and I've written 6 as the product of two prime numbers. Let's have a look at number 12. Let's put that in my factor bug. I've got quite a few more factors for this. It's going to be a little bit bigger. So I've got 1 and 12. Again, I've written them in pairs, so 1 times 12 is 12. 2 is a factor as well. The factor pair is 6. 2 6s are 12. 3 is another factor. Its pair is 4, and so 1, 2, 3, 4. The pair of 4 is 3, which we've already got, but I know I must have all of the factors of 12. I've got 6 possible factors. 12's not prime, that's an even number. 6 and 4, they're both divisible by 2 as well, so they're not prime. 1, we've already talked about, not a prime number. 2 and 3 are prime numbers, so I've got 2 and 3. So my number 12 I can write as 2 and 3. They're both factors of 12. If I multiply 2 by 3 I get 6, so I'm not quite there. I need to multiply it by another 2. So I've got 12 is equal to 2 times 2 times 3, just reordering it, putting my 2's first and then my 3. So 2 times 2 is 4, times 3 gives me my 12. The factor bugs will only work so far. As soon as your numbers get bigger, they're not very helpful for us, and we're going to need a new technique. And that's called factor trees. So what we're going to do is we're going to start off with our number 12 that we've just looked at, and I'm going to break it down into pairs of numbers. They're going to be factor pairs, so I'm going to choose to break this down into 2 and 6. I could have chosen 3 and 4, because 3 and 4, 3 times 4 gives me 12, so that would have worked. 2 and 6. 1 and 12 doesn't really get me anywhere because I've got a number I started with, and remember 1's not a prime number, so it doesn't really help. So 2 and 6, or 3 and 4. As soon as I hit a prime number, like 2, I'm going to put it in a circle. I know that I can't break that down any further. It's only going to break down into 1 and 2, number itself, and 1 which is not a prime number. So as soon as I hit a prime, I'm going to circle it and stop. 6, however, is not a prime number, so I can break that down. So I'm going to break that down into another factor pair. I've got 2 and 3 multiply together to give me 6. So it's the only factor pair that's going to work for me. 1 and 6, again, doesn't get me anywhere. So 2 and 3, both of these numbers are both prime numbers. 2 and 3, so I'm going to circle them. I then know I've picked up all of my primes. So I can then write that out as 12 is equal to 2 times 2 times 3. So have to remember these multiplication signs. If you're writing it as the product of prime numbers, you can't just list the primes out, you've got to put that multiplication in, otherwise it's not a product. It's got to be written as an equation, so 12 equals 2 times 2 is 4 times 3 equals 12, and do the check. So 2 times 2, 4 times 3 is 12, that's the number that I started with, and I'm happy. So that is called product of prime factors. There's one final step that I'm going to do, and that's looking at this bit here. I've got 2 times 2. I can actually simplify this a little bit further. Instead of writing 2 times 2, I can write it as 2 squared, so 2 times 2 times 3. This last format is known as index form. So if you ever see a question that says write a number as the product of prime factors and write it in index form, you get method marks for getting this far. If it asks for index form, you've got to write it, recognise that 2 squared is equal to 2 squared times 3. So this is a correct product of prime factors, and this is the correct index form for this number. Now there are a couple of possible ways I could have broken this down, but it always would have ended up in this breakdown, this product of prime factors and this index form. Let's have a look at another example. I'm going to have a look at 90. So again, I'm going to start by splitting that into a factor pair. I'm going to pick 2, which is a prime number, and 45. Again, there's some different possible options I could have chosen from here, but I'm looking for 2 numbers that are both factors and both multiply together. They're both a factor pair, multiply together to give me 90. So 45 is not prime. I can split that up into what we're going to choose, 3 and 15. Well, 3 is a prime number and 15 isn't, so I'm not going to circle that number. So these branches here, I've stopped because I've hit my prime. 15, I need to keep on going. So 15 I'm going to split into 3 and 5. 3 is a prime number, 5 is a prime number, so I've stopped. I've got no extra branches. I've got circles at the end of each of them, and now I've got my product of primes when I write it down. So 90 is equal to 2, my first number, times 3 times another 3 times 5. Sometimes you might want to tick them off as you've done them. This one was really convenient because the numbers came out in ascending order. I had 2, 3, 3 and 5, and sometimes they don't do that, so you might have 2 here, 5 and 3's over here. You can either write it out not in ascending order and then order them, or you can write them in and then tick off the ones that you've got, but always do that check at the end. So 2 times 3 is 6, times 3 is 18, times 5 is 90, and I know I haven't missed any off. So that's my product of prime factors. I just need to write it in index form, so I've got one lot of 2, 3 times 3, or 3 times 3 is 3 squared, and I've got 5, and I've got them written in ascending order, so I've got my 2's, my 3's and my 5's, and I've got my index form for my product of prime factors. Okay, I'm going to have a look at one final example. Let me flip that one over. I'm going to have a look at 150. I'm going to choose to split that into my normal approach. I'm going to split with 2. If I've got an even number, I often use 2 as one of my factors, and then now all I need to do is half this number. So half of 150 is 75. It's definitely not prime. It's going to be divisible by 5. 2, as always, is a prime number, so I can circle that. 75 I can split into 3 and 25. Again, there's a couple of different ways I could have done that. 3 is a prime number, I'm going to circle it. 25 I can split into 5 and 5. 5 times 5 is 25. 5, 2 5s, both prime numbers. I've got my product of prime factors. Got my 150 is equal to 2, first one, times 3, times 5, times 5. So we've got 150 equal the product of our prime factors, 2 times 3 times 5 times 5. Just need to pop that into index form, so that's going to be equal to 2 times 3 times 5. I've got 5 times 5, 5 squared. 2 times 3 times 5 squared. Do that double check. 2 times 3 is 6, times 5 is 30. 30 times 5 is my 150. It's looking good. Just want to show you quickly, if I were to use a slightly different tree from 150, or one of my factors of 150, 10 is always going to be a good one, and 15, neither of those are prime. I break that down, I've got 2 and 5, those are both primes. I can break my 15 down into 3 and 5. So this tree looks completely different from this one, but we've got exactly the same primes on the end of the branches. So we've got 2, 3 and 2 5s, 2, 3 and 2 5s. Doesn't matter how you break them down, you're going to end up with the same product of prime factors and same index form. So 150 equals 2 times 3 times 2 lots of 5, 5 times 5 times 5 squared. You get the same answer. So it doesn't matter which ones you pick. I often pick 2, just so that I know all I need to do is half my number, half 150, 75. Doesn't really matter. Pick your numbers, carry on breaking it down. It really does help though if you circle your primes, because then you know that you've got to the end of each of your branches. Okay, time for you to get some practice, so have a read through your instructions and have a go at the exercise.